Yes, device is transformer. Transformer is a device which does what? It is used to increase the voltage, decrease the voltage, and rarest of the rare, voltage remains same. That is termed as an isolation transformer, not required for our purpose. What is input to the transformer? Electrical power. Output is also electrical. So it is a device which changes from electrical to electrical. Then what is the use? To change a voltage level. We need different voltage for transmission, different voltage for domestic supply. We need different voltages at different levels. So transformer will do what? Change voltage levels. Construction, first part. So first you take the core of the transformer. One lamination, like a thin sheet, thin metallic sheet. You can say like this one. Even you can say less than this, fraction of an mm. One. Then you place second, third, fourth, like in a book. You have pages. Similarly, you have these thin sheets, and transformer appears to be. Of this, you find these layers. Why? The purpose is to reduce eddy current losses, so that heating can be reduced. That is why laminations. One, we will have a two-dimensional view. That means front view. So this is first part. Core. Core is made up of what? Fine quality iron or steel. Nu R is equal to 1000. High value of nu R means what? Permeability is high. It is a good material for conduct of a magnetic flux. One. Then you have winding. Input is alternating current, applied voltage is V1. This side in which you inject voltage is termed as primary. Primary winding. The other side, from where you have output, say you connect a TV set across the same, is termed as secondary. You can change the voltage level by changing the number of turns. If voltage on this is say 100, you want to get less than 100, decrease the number of turns on the second side. Suppose the number of turns in the first side is N1, number of on the second is N2. If N1 is equal to N2, voltage will remain same. If N2 is less, voltage will be less. So regarding construction, one, transformer is a device used to change AC voltage or current level. Core is made up of soft iron lamination. Nu R is 1000 more. Core is in form of laminations. 2. Decrease eddy current losses, heating. Input is given to primary. Load is connected across a secondary. Number of turns of primary N1 can be less than, equal to, or greater than number of turns N2. So if N1 is equal to N2, voltage level remains same. If N2 is less, voltage is less. If N2 is more in comparison to N1, voltage is more. Thickness of wires depend on current to be carried. If from this side to this side, for example, as shown in the diagram, N2 is less, so voltage will decrease. Power is equal to what? V into I. If voltage decreases, current will increase, power remains same. Assumption, no loss. If current has increased, wire used to carry that current has to be thick. In competition, sometime they will say thin winding, thick winding. When say thick winding means the winding which can carry more current. If it is more current, the voltage will be less. So, in this case, this will carry more current. This winding will be thicker in comparison to the other winding. Thick winding in comparison to the one. Thickness of wires depends on the current to be carried. Primary and secondary are coaxial. This is theoretical model. Practically, it is first this limb, first winding primary. On the same you have secondary winding on the same coaxial. Why? So that flux leakages are less and flux connection or mutual induction is better. But for theoretical model, we show primary on one side and secondary on the other side. 4 minutes with you to write construction of a transformer. First part, construction. B part deals with what? Working of a transformer. Point number 1. EMF per turn remains same. EMF is what? Rate of change of flux. Flux throughout the throughout the magnetic core remains same. So if you have one turn, EMF induced will remain same, whatever be its thickness. So the working principle is EMF per turn is same. Here applied voltage is V1 and EMF induced is E1. The two are connected the two are in parallel. So whatever is magnitude of V1 same as E1. So if you want to write it like this, E1 by N1 is equal to EMF in the secondary, suppose E2 by N2. E1 is equal to what? V1. V1 by N1. Suppose in the secondary EMF is E2, voltage is V2, then it is V2 by N2. As an example, suppose here it is 1 volt per turn. Suppose it is EMF per turn. As an example here is 1 volt per turn. V1 will come out to be what? Anyone? 1, 2, 3, 4, 5. How many turns are there? 5. Voltage for 1 turn is 1 volt. For 5 turn, 5 volts. So V1 is 5 volt. V2, yes, 1, 2, 3, 4. 4 turns are there. What is the voltage per turn? 1 volt. 4 turns are there. It is 4 volt. V1 by N1, 5 by 5 is 1 volt per turn. V2 by N2 is 4 by 4 is 1 volt per turn. So the working principle is this. One of the competition question, rarest of the rare, but it was there. That there is another winding here, tertiary winding, with the 2 turns. What is the voltage across that? 2 volt. Working principle remains the same. Voltage per turn remains same. So if you have a tertiary winding is also there, possible. It is there for your transformer at thermal power station Bhatinda. That is used to have use for its own plant use. That is why you can have any winding. You can have 4th winding also. Whatever be the number of windings. The working principle is EMF per turn remains same. 2 minutes with you to write. Point number 2. Yes. Point number 2 deals with what? Law of conservation of energy. Ideal case, energy can neither be created nor destroyed. If I assume this transformer to be ideal, means no loss, then input power is equal to output power. P in is equal to P out. What is input power? V1, I1. Output power V2, I2. And with this one, if you know V1 by V2 is equal to what? I2 by I1. This is one. It is also true voltage per turn remains same. Previous part V1 by N1 is equal to V2 by 2. V1 by V2 is equal to what? V1 by V2 is equal to N1 by N2. So, if you know the turn ratio, you know the voltage ratio. Whatever is the turn ratio N1 to N2, same is the voltage ratio. But current is inverse, reciprocal of the same. 2 minutes with you to write. 2 minutes to write. It is with an assumption, no loss. Point number 3, practical transformers. Yes, transformer will have a core, that means losses. Transformer will have winding, that means losses. Heating loss. Heating loss in form of copper loss and winding. And in this magnetic material, hysteresis loss, vibration, all those losses are there. That means what? Practical transformers have losses. So efficiency of a transformer is equal to output power over input power. If not given, then we will assume the efficiency to be 100%. P output is equal to what? V2 I2. And input is what? V1 I1. If you want percentage efficiency, then V2 I2 over V1 I1 into 100. 2 minutes to write. 2 minutes to write. After completing this, refer to the numericals, chapter 4C. 4C. Numerical number 10. Deals with the transformer. Question is, the primary coil of an ideal, underline ideal, means what? No loss. Ideal step up transformer has 100 turns and transformation ratio is also 100. The input voltage and power are 220 volt and 1100 watt. That means what is given is, yes, what is given is input voltage V1, yes, 220 volt. Number of turns in the primary, yes, 100. Input power V1 is 220, N1 is 100, P1 is 1100 watt. Data about primary is given. Find one by one. First part, yes. Number of turns in secondary. Find number of turns in secondary. N2. Transformation ratio is also given. N2 by N1. It is also given. N2 by N1 is also 100 given. Transformation ratio is given. Yes. Find N2. Yes. N2 by N1 is given. 100. N2 is not known. N1 100. 100 into 100 is what? 10 raised to power 4 or 10,000. First part answer. Yes. 10,000. You have to find out. One you have answered. N2 is 10,000. Second. Yes. Find what? Current. In primary or secondary? Yes. Primary. I1. Find I1. Try by any formula. I1 is equal to what? Find I1 by any formula. Power, voltage, current. Yes. Power P2, P1 sorry, is equal to V1 into I1. P1 is what? 1100 watt. V1 is 220. I1 we don't know. Solve and find out I1. 1100 by 220, 5 ampere. This current I1 is 5 ampere. Third point, voltage across a secondary. Third point is find voltage V2. One minute to try. Hint, voltage per turn remains same. Voltage per turn remains the same. Yes. As per this principle, V1 by N1 is equal to V2 by N2. V1 is how much? 220 divided by N1, number of turns 100. V2, yes, you have to find out. N2, yes, number of turns in the secondary 10,000. Number of turns are 100 times. Voltage will also be 100 times. Objective question, fast calculation. Number of turns are 100 times. So it is 220 into 100. 22 into 1000, that means 22 kilovolt, 22,000. 22,000 volts. Fourth part, current in secondary, I2. Number of ways to do this. Yes. If you have to find out I2, your choice. V1 by V2 is equal to V1 I1 is equal to V2 I2 is equal to V1 by V2 is equal to N1 by N2 is equal to 100 by 1. So I2 by I1. No. Yes. N2 is 10,000. So it is equal to 1 by 100. I2 is equal to I1 by 100 is equal to 5 by 100 is equal to 0.05. Last, fifth point. Power in secondary, yes. Fifth point is power in secondary. Ideal case, ideal transformer, P1 is equal to P2. P1 is how much? Yes. P1 is how much? 1100 watt. So P2 is also equal to same 1100 watt. So P2 is 1100